So what do we got today? We still working on surface area and volume?
Kind of. It's like... So pretty much what it is, it's, I gotta get this. Okay. So it's like, each of the space figures below was assembled using different combinations of the pieces shown above. Calculate the total cost of each figure.
Okay.
And then there's a picture of a square, and it's 32 cents. So these are like the key.
Okay.
And there's like an equilateral triangle, and that's 15 cents. And there's a isosceles triangle, which is 30 cents. And a rectangle, which is 64 cents.
Okay. Now what?
Okay, and then it kind of just gives me three-dimensional figures. It tells me to find like the surface area of it. So, or like not the surface area, the price of how much it would cost to make that thing.
Okay.
So there's a picture of a rectangle, and it's 1, 2 rectangles, and then there's a rectangle on the back.
This is going to be hard to do. These are the things that are hard to verbalize.
Yeah.
I mean, I can attempt to draw what you're talking about,
Okay.
but it could be tough.
All right. Yeah, that's right so far.
Okay.
And then it's on the side, it's a square. So it's like 2 squares on each side, and then 4 rectangles. And you're supposed to find like the cost.
Okay. Why don't you give me the dimensions? So it's 2 squares, so it's really kind of like this.
And there are no dimensions.
Okay. I think I know what you're looking for. So the surface area would be 2 times 32 cents, right? In other words, this one's 32, this one's 32, and then there's 4 rectangles. Each one of them 64.
Yeah.
So the cost is going to be 2 times 0.32 plus 4 times 0.64. If this is the figure that we're talking about over here, where it's a prism, rectangular prism that has 2 squares as opposing faces. Okay?
Yep.
All right. What else?
Okay. Then there's a triangular prism with a rectangle on top and so yeah. Or there's like it's upside down. It's an upside down square-based pyramid. That's hard.
Upside down square-based pyramid.
Pyramid? Yeah.
So this isn't a correct drawing of it?
No.
Square-based pyramid?
Yeah.
Something like that?
Yeah. Sometimes it's just the other way around, but that's fine.
Okay, shouldn't matter.
Yeah,
So,
and it's the 15-cent triangles.
okay, so what do we have here in the way of faces?
32-cent square.
Okay, so it's 1 times 0.32.
Yeah. Plus 4 times 0.15.
Times point what?
1.5.
Are these equilateral or isosceles triangles?
Equilateral.
For sure?
Yeah.
Okay. Because you can't tell just because it's a rectangular pyramid. They don't necessarily have to be equilateral.
Yeah.
They could be isosceles. In other words, if you made this point higher up, then they would be isosceles triangles.
Yeah.
Okay. Okay. Well, these are fairly straightforward. These don't, any of these seem too difficult. They're not even asking you to calculate surface area. They're really just asking you to count the number of faces and what shape are they.
Yeah. It's really easy.
Yeah. So are there any you don't know how to do?
No, not particularly.
Okay. Well, we certainly don't need to just spend time doing problems if you know how to do them.
Yeah.
It's fine with me if in a situation like this you just want to cancel, or we can do a short session or whatever.
Yeah, I mean, well, I have a session on Tuesday, which I know we're going to get into harder stuff. So, like, this upcoming week.
Okay. And again, that will be the only day I can really see you. Notice my Thursday on is canceled out. So this Wednesday will be stacked, and so will that Tuesday. So let's just plan on doing 4 o'clock at the library. And you want to get the room for that? Do you know how to do it online?
Yeah, I do.
Okay, why don't you go online and see if you can reserve a room for Tuesday at 4.
Okay.
And I'll see you at the library.
All right, thank you.
Okay, Michael. Bye-bye.
Bye-bye.